the translations. So you try to translate from one domain to another domain, right? You try to translate the language, right, from one domain specific, or just within the domain.
Sorry, no. I only focus on one domain, but for this domain, we may not have very rich data. So I use mix the domain data to only focus on one domain.
My first question is the general question is you focus on the within the domain, that means domain specific, or you try to translate cross domain, translate the article or the sentence, whatever, translate within the domain or cross domain.
I think within the domain.
Within the domain.
Yes.
So for example, you try to translate the medicine, the article. So because I see you in your presentation you talk about say okay domain and general, okay, general domain. So it seems you actually translate cross domain. That means a specific domain and a general domain.
Yes. I think this is my definition. I only want to translate one specific domain. For example, it is medical domain. But I have a small piece of general domain data which cannot help me to train a model. So I use a general domain. It is very large. Maybe some of data are related to medical domain. So my work is to want to select a small piece, but relative to the medical domain data to train the system.
Okay.
If we have an in-domain corpus, now we can combine this select piece and the in-domain data to enhance this model.
Yeah, I mean, what I mean is, do you intend, okay, try to say you translate, say from here in Chinese, okay,
Yeah.
you actually the article is in the Chinese medical the domain, and then you probably translate to English, and then probably your audience, okay, because you are focused on the domain specific, okay, and you try to see another domain to your article is to the general English audience.
Yes. I think
it is not just to teach the reader. Actually, it's trying to translate some technical domain.
Okay. So that's actually why. So you actually say your translation is the specific within the domain.
Yes.
Okay. So then in that case, I can make assumption say. So in the same domain, you will have the exact say the grammar, okay, the syntax, and you also have exact the knowledge like the sentence sequence, okay. So the problem is that when you translate from one language, say English or Chinese to English. So if they during the translations, okay, for example, okay, in Chinese, okay, you have a Chinese the Chenyu, okay, and to English domain, then you have no such things, okay. So now you rely on actually, I think it's the external hops, external hops, or even through the web crawling, okay.
Yeah.
So if you cannot find again, then through the outside external the corpora, or the crawling data or whatever, okay. And how do you handle process such kind of things?
I think the one word, a terminology word, or the Chengyu, for example, does not occur in my in-domain corpus, or even not occur in my
No. That's only example. I mean,
yes,
similar things. Okay, that's only example. such that, I mean, the things, okay, you cannot find in the within the domain the cops and the external domain cops and even those data crawling okay, from the web. So how will you handle? Do you have any rules to handle such kind of unexpected things?
I think if it does not occur, it will be OV. That means it cannot be translated. But to my opinion, we can still deal with these terms. For example, we don't know how to translate. This is, for example, terminology. But we can also keep the original format that not translate, or just translate to pinyin. For example, the Chengyu. We don't know how to translate well into the English. But
okay, so that's your rule. So that's actually no action.
Yeah.
No action.
No action, because in corpus, in websites, there is no match.
Okay.
Yes.
So I guess, okay, if the difficult domain, you will have a lot of no actions here in between the translations.
Yeah, that's why some companies, for example, I give this. For example, these companies, they both apply some statistical method, but also employ some people manually to create some annual words. I work in this company. I see they will apply some new methods for example, the domain adaptation to improve their performance. But mostly, some words still do not occur in the website or the corpus. So some linguistic people will manually create these terms to increase the performance a little by little.
Okay.
Yes.
So you have no for the do you have any of your own grammar, any translation grammar for coordinating the sequence, you know, the word sequence between the different language? Do you have any of your own grammar? I mean, that means the translation grammar.
No, I don't have grammar.
So you all what you have done is based on the course, bilingual course, right? Bilingual course,
yes.
Or the example.
Yes, for data selection it is like that. But for web crawling, we may to identify which is the in-domain website and cloud the in-domain data and the future.
That's why I say everything you have your depend. Okay, what you have depend is on the bilingual course or all the older data you have already matched between the languages.
Yes, for data selection, the aim is to select the better data. This is data selection.
So, okay, actually that's the suggestion. So why do you have create a small bilingual grammar? Then that's what can make some unmatched things, you know.
Because you see, right now in machine translation, we are moving to the trend. It's based on statistical approach.
Yeah, I know.
And I think it's true also, especially in this era of big data. Some resources they are very easy just to crawl the internet, just like Google. So we put more effort in, say, the model how to automatically to learn the translation. So actually you can see in the flow chart, the model is based on the given esoteric corpus, and he learned the alignment information, he learned the translation phrases, and used the reordering model to reorder the sequence of the source and the target language just to match the target language syntax. So actually we are very few to add any manual rules just to influence the model.
Okay.
So actually, at least in his case, it's totally statistical.
Okay. Is it possible to say given the translated the data to then based on the translated data to generate the new translated the info the new translations?
No, I don't think so. But for your last question about some grammatical rules, I think for example we still will apply some small rules to deal with some specific case. For example, this is a chemical formula. Here in this translation, we do not just train a model based on the copper, but we also will split them because we can identify which is chemical formula. And if we want to translate it well, we want to split it the hyphen and keep hiding the numbers because the two can change to any kind of numbers. I think I also do some work on some grammatical rules to deal with some specific case. For example, this is why I call it numeric adaptation and hyphen word adaptation.
That's actually
Yes,
similar.
yes, some rules students can deal with some specific domain, but this may not can apply to other domain because this is only medical domain case.
Okay.
I mean, yeah. Thank you.
It seems you have done a lot of work, but I am not very clear about what do you mean by the domain adaptation. You just mentioned you are just try to get the corpus from the external sources and for a particular domain. So you have just one domain,
Yeah.
right?
Yeah. For every task, I will assume what domain I want to translate. Just assume one domain.
So
For different
what do you
domain.
mean by the domain adaptation? Because you just try to translate the domain from the some external data. You may select the domain corpus for this domain.
Yeah.
But so what do you mean by the because when I see your title domain adaptation, I thought that your translator can adapt to different kind of domain translation. For example, we can translate medical and at the same time we can translate law or maybe something.
Yes, you can say that because we can set the medical domain and select and build a medical domain model, and we can also set another domain. For example, the dialogue domain. We can also from the same general domain corpus we can build another model, use another adaptation method. So from the same general domain corpus we can deal with any domain you want to translate. Yes, it is just you can imagine.
Okay, that means you can switch your translator into different domain.
Yeah.
But you need to retrain your model, right?
Yes.
So totally retrain, right?
Yeah. But data selection is only one method for domain adaptation. Domain adaptation can be applied in many methods. For example, we already have the model, but the model is for each sentence pairs, it has different weights. There is a online method. We give an input. We don't know what domain it is, or we don't assign what domain it is, but we can calculate which terms it is similar to which domain, and we can weight our parameters and do this task. This is another method, we call it instance weighting.
That means you can detect the source tag is which domain?
Yes. For example, we have some corpora or some data, the medical domain, the dialogue domain, or others, and we can build them, build the language model. Give a sentence, we can use the different language models to score the sentence, and according to their score, we can guess which domain it is, and then we set our the parameters in our trained model, and this is another method. We call it instance weighting. It is an online method. no need to build a model one by one. We just build one domain. But
have you done this or just?
I don't think that method is good, so I didn't do that because it have a lot of noise, and the method maybe not very right, So I do the data selection to try to filter the noise, for any noise, keep the model clean.
Yeah, I think this is not an easy problem, and also when you have this domain, okay, you select the data from the web or from some domain. So how do you know? For example, in the web, how do you know the corpus in the web is medical or law or some specific domain, and you select from there?
Oh yes, the assumption that is that we should already have, for example, this is you mean, for example, this is general domain, maybe we already have it or from the website.
Yes.
But another assumption is it is easy to get a small in-domain corpus. We can use this to measure which data is better. So here I give a abstract function. I call it the score function. We can use, for example, the editor distance to measure the distance between them and to see which part is similarity.
So that means you already have some in-domain corpus or data to score, to compare with the general domain, and so the one that matches your in-domain, and then you so
yes,
is this reliable? If it's reliable, you can use the same way to detect the input document. Is it this domain or not? Right. Yeah.
This is actually, I think, this is the adaptation problem. Yeah.
Maybe I can provide some information. So actually in the adaptation, actually what he did here, this part, maybe it's a small part. You can say it's a preprocessing how to adapt based on a data selection model. For example, if it's data selection model, you can select different corpus. And actually, different corpus can train up different model. And this model actually can be integrated as a final. So based on the input domain, you can try to use a different model for training, for translate the target domain. That's okay. So here you have a data selection. You have a model integration. So the model, that means you can create individual model for different domain text. So by the time doing the application, the translation, so which model to use? Just the selection. So he just focused here right now is the data selection part. He did not talk too much about, the online detection for the text, but actually it belongs to the part what we call the adaptation in the SMT research.
Yeah. And also there's sometimes the same paragraph. It cannot easily classify into medical or general or maybe some kind of mix, mixed domains. So how do you handle this?
So that's why we said key is a tunable threshold. We just rank the sentence from top to from top to down, but maybe they are mixed. But what we only want to do can do is we set a key and select the top 3% as it. That's why in my experiment I set key at 20, 40, 60, 80 to show which point it give the best performance. We have developed that data. We already know its translation which is right. We can before the real life translation, we can use the developed set to get the best threshold key and use this model.
The problem now about is that for our sense, domain adaptation is that I train a course or, for example, a test in sports domain, and I use those knowledge to translate medical domain.
Yeah.
Okay, this is domain adaptation in our sense, right? So I train a knowledge or a model in some sports domain, and then use this model to test or to classify the sport medical domain. So this is domain adaptation. So you mentioned domain adaptation, but you are doing the data selection. So what the relationship between your data selection and domain adaptation? Actually, your data selection is to do data selection to improve the performance of your domain adaptation. So I think you should explain how, for example, why, for example, I train a irrelevant domain, and how your data selection can improve this model to translate your medical domain. Yes.
Because your title is called domain adaptation. It means that you can adapt your domain to different domains. Even though you have no knowledge about the new domain.
Yes. Yes, but
No, I think data selection is one method or one way to improve the performance of domain adaptation. Since domain adaptation, if I purely to train a sports domain, the model, and use this model to test or classify the medical domain, the accuracy will be very poor. So how to improve the performance of that model? So data selection is one way. That means we can choose some data or some test which is quite related to your target domain, medical, and put as much as possible all those knowledge into our model. And then we use that model to classify the medical domain. That will be, the performance will be high. This is one way to improve the performance of the domain adaptation.
yeah, actually now the data selection is a key method for domain adaptation. Yeah.
Maybe in our community, just as I say, because we just focus on the data selection, we are not talking about as a whole picture about implementation. Maybe for example, in Google, when they are doing about the view line system, they will prepare a lot of models. So the model just fit to medical or for the sport or for the other chemical, for example. But in between, when they create a model, they have to do the data selection. So that's the first step when they create a model, not for the end for the application. So you can imagine that's the resources that we have. The resources we have is a general domain. So the rest you do yourself. So how can we adapt this general data to a specific domain? So that's the task of what he's focusing on. So you can understand in this way.
Yeah, actually, good research. Good research. We call it good, so we ask.